Alright, we just landed in Munich and there will be a trade show. One complete week. The Automatica, the laser world of photonics and the world of quantum in these halls. And I will be there for 3 days and I want to investigate what people are doing in real life, which we are doing on the channel in our simulations. So I will take a look at real robotics, at robotic simulations in industry, in point cloud generation for three-dimensional views, for laser systems and cameras and all of this. And today I want to give you a little teaser, mainly from the Automatica, and you can write down in the comments what you are interested in especially, and I will try to then go to these booths and interact with people, see what they are doing and create nice videos that you can get the best experience of the Automatica or the laser world of photonics, even though you're not there physically. So let's dive in. For today's video I will mostly cover these 3 booths or these 3 halls because they are about machine vision, about sensor technology and about industrial and service robotics, as well as the startup companies. So let's get started with the robotics hall, where we directly see the applications in hall 4.
And now, we're introducing another game changer. Meet the all-new UR15, a sharper, faster, more agile cobot.
These robots here, these collaborative robots, exist already for a very long time and people made a huge improvement of them. Many people developed like little toys with which you can play to understand the principle. And one of them I also organized myself for this YouTube channel because these things are nice to also teach programming on them. So there are little microcontrollers with which you can then control the robot's movement. And that's very nice for teaching purposes. So if you're interested, we can also take a look in how this works and how we can control them. The cool thing about them is that they are very simple. So what we basically have is here some little motors, not as advanced as it is, for example, in the video I showed you, but these are little servo motors and you can basically control how much they are rotating, and this gives you the movement of the robot. And then you have here also a little robotic arm, which then can grab something or perform some other tasks. And since we're talking now about robot arms, we are coming to our next very exciting presenter at the Automatica. It will be a company that produces robot arms that have a feeling, that have 4 sensors inside. So let's take a look what they offer. So as you can see here from HI Robots, they produce a robotic hand that has many joints, like a real human hand. So there you can control to grab something very precisely. It's way more precise than in this tool here. And what you have on top of this is that you have multiple sensors inside these fingers, so that you also can measure forces or torques that you apply on something like, for example, a glass, so that you do not break the glass. And that's really advanced. What I also have is something we have not talked about yet in this YouTube channel, but this will come up in the future. It's programming and having an interface with robots. And there is something very famous at the moment, or very widely used. It's the ROS, Robot Operating System, and that's an interface which I want to show you also in one of the upcoming videos, when we dive more into how we can make actual robot simulations. And so let's take a closer look what I mean. So ROS is a tool which is used in robotics for communication, for actions, for listening to some sender, to receive some data, but it's also used in Gazebo for simulations. So let's take a look, for example, for our collaborative robots. So here we have an example of a robotic arm, something like this, but more advanced, but not in real world, but as a simulation. So we have our simulated robotic arm with its joints which can move, and we can have full control over it in a physics simulation. So we can play with it, we can train something. So for example, we can train it to pick something and place it somewhere else, and this without destroying anything, which is very good, because then we can practice millions of times, like we did also with our football player in the video which we had last week. And this we can train until it's also an expert in performing a certain task. Let's take a look at another example. We can take a look at this robot where we have basically a lot of joints which we can control, like for example here for the leg, or if we go a bit higher for the head, this joint which you can see here. And all of these joints can be controlled by motors. So every joint has basically a servo motor, some other type of motor, a stepper motor for example, which we control as an action. So if we train our reinforcement learning robot, then we have an environment. We get, for example, with cameras in the eyes, visual input, and then the robot can perform actions by moving certain joints. So maybe I can find it fastly, some joint that makes the hip, and then we could make a step to some direction. Yeah, doesn't matter. You got the principle. And these kind of simulations I also want to show you if you're interested in it, because this is something which is actually used in robotics, in industry, and it's very useful. And now we want to switch to a company that is working with these techniques a lot and very advanced. So we are switching now to humanoid robots, which we will also see at the Automatica. So now we are moving on with another big name in the robotic industry in Germany, which is Neura Robotics. And as you can see already in the preview, they work with a lot of types of robots, especially also interesting for us, the humanoid robots, which I just showed you. So these ones I will definitely observe when I'm at the Automatica next week. And these humanoid robots are basically something like a human. They have a weight like a human, they have a height like a human, and they have fingers, they have legs. In these fingers are sensors and so on. And the very cool thing about them is that you can also get them as a simulation for training, where you have, and I hope you can read this, reinforcement learning support. So you can basically train a robot, for example walking or performing some lifting task and replacing task. You can simulate all of this, and then a real machine can do the job. And they are very advanced in this. So let's take a look to visualize what I just tried to describe. Here it's how they go from a simulation to the reality of movement. where we have here the simulations running in Isaac Sim, so not in Gazebo, but in something which comes from NVIDIA. But there is some interface with ROS and Isaac Sim, which we could also cover in one of the following videos. And there they basically have simulations of the robot itself. And here they try to teach the robot via reinforcement learning how to stand. You can take a look again. Then the simulation outcome, so this neural network or this brain of the robot, can be used inside this one, and with information from all the sensors that are included, it can basically come to the same output, a robot that can balance itself, so it can stand without falling. And yeah, then you can create this in a kind of realistic environment where you have here tables where you can have this pick and place tasks like shown here, where basically the robot first can simulate how to pick something and then perform this in practice. So really cool stuff, and I'm very curious on seeing this live next week. So that was a little teaser for the whole B4 with neurorobotics, universal robots and agile robots, but there are many more to take a look at next week. Alright, so let's move on to our next topic, to Hall A4 with machine vision and with sensor technology for industrial robots. Alright, let's continue with one of my favorite types of sensors. These are camera and vision sensors. For example, the company VMT will show their skills on the Automatica, and they have camera systems which are able to make three-dimensional captures. This they can support with laser technology. Laser technology helps to get depth information more accurate than cameras. So this is, for example, what we used in our Unity machine learning environment as LiDAR systems, so laser radar kind of. And they use this in the real world to measure the depth information of systems. So for example, if we take a look on their demonstration, where they have the camera systems set on a real robot, like on this collaborative robots, and then you can measure the three-dimensional space in real time. So here you see the sensor scanning the surfaces. Right, here's the sensor. This is on top of the robot arm, and then they have multiple cameras and lasers, and also then the receiver of the laser light, with which they make a three-dimensional reconstruction of the surfaces they are scanning. So if they, for example, scan over this surface, you can see here differences in the width, but you can also see that this is three-dimensional, so there will be differences in the height as well. And when they're done with their measurements, they have basically a two-dimensional image with, in color encoded, a third dimension, so the height profile. And then they can measure if the lines which they should produce are too wide or not, or if they are too high or not, and then they give out some information. So for example, here is written error, the height is too large. And this is basically very useful for robotics when you have a good understanding of the three-dimensional world. Alright, so let's move on with another company. This company, which we're talking about now, is called Houston. And no, they don't produce these robots? They produce sensors. Together with Zeiss, they have produced sensors which can directly measure three-dimensional structures and create them in so-called point clouds. Point clouds is something we will definitely cover on this YouTube channel, because this is a two-dimensional image with a third dimension of the distance encoded. And then instead of something which we can understand like here this text in 2 dimensions, we get a third dimension where every pixel has a certain distance from the observation. And this is very useful, because then for robots, you know from the 2D camera maybe, this is a house, this is a street, this is a passenger on the street. And with this point cloud representation, you also know how far away is the person on the street in front of your car, which helps the robot to make decisions on reacting on the person on the street, for example. And yeah, they basically produce these 3D point cloud cameras, which is very cool. So here's a little example of a point cloud. When we have here this object, it looks from one perspective like something two-dimensional, which has information, but we can also rotate the object, and then we can see that there is three-dimensional information. So for example, we see that here is a window of so the complete thing is a house. Here's a window of the house, and we can watch through the window and see the entry door of this room. We can also see here on the top is maybe something like a lamp, and so on. So we basically have a three-dimensional information in something called a point cloud. It's called a point cloud because basically what we have is little points, and they have X, Y and Z dimension. And these kind of things can be produced directly with the cameras. And that's very helpful, and this I would like to see on the trade show next week. So these 2 companies which I just showed, they are together with many more companies in Hall 4 for machine vision, and you can see them here and here, but there are also way more companies to look at. Alright, and now we're coming to Hall B5, which is the machine vision, sensor technology and industrial robots hall, and there's a lot of cool stuff going on. So let's take a look. So in the Hall 5 there's one, to my mind, very interesting company, because they challenged the concept of cameras entirely. Here we see something which is not like a normal camera that makes images frame by frame, always like full HD, millions of pixels at the same time. No, they produce event-based cameras. So these are cameras where you have like a static image and you're only interested in the movement in the image. So if we take a look at this image, so this is one frame, it has, let's say, 1000 times 1000, so 1 million pixels or 1 million information points, but most of them are not moving. The only thing that is moving is the arm here. So why should someone stream in a frame based, like a normal phone camera? Why should someone stream 1 million pixels all the time? That's a waste of information. So they instead set everything dark, which is static, which is not moving, and everything which is moving will be recognized. And then you see all the movement of the hand here without problems as basically points that are moving in time, and all the rest is static. It will not change, so it does not have to be recalculated, and this makes the complete process super fast. By the way, these kind of cameras, these event-based cameras, can be found in nature for cold-blooded animals. So animals that don't have much energy to spend on their task and also on their kind of sensors. And they try to reduce the energy by having eyes that can only see things that are moving. So basically some snakes or frogs, when they are hunting their prey and the prey walks by, they see only the movement. So everything else they don't care because it's kind of black for them, and they see only brightly and shiny the movement of their prey. But the thing is, if the prey stands still and doesn't move, the hunters also don't see the prey. So you sometimes have in nature these situations where a hunter looks at a prey and then the prey just stops and doesn't move at all, and it actually works in nature because then the hunter with this kind of vision system cannot detect the movement anymore. And that's quite interesting to my mind, and it's cool to see that this is also working in nature, very energy efficient. Alright, so let's move on to the last topic for today, which is a field in which I was working quite a lot in the past and I really enjoy it. It's the field of image segmentation. And now we are coming to a company, I mean many companies are doing this, but one company that will be on the Automatica, which is basically taking camera images like these here, and then they detect objects inside. So this process is called segmentation, where you try to identify objects within an image, and then once you have like the outlines of the object, you can do multiple things with them. So here in this easiest case, they just count them. But what you can also do is you can measure distances. You can see the rotation, the alignment. You have the outlines, which is important if the robot arm wants to grab it. You see also empty boxes, and these are things where the robot knows, okay, here I can place something. And you have a lot of information. So this kind of segmentation is, to my mind, really the understanding of the image, and to give regions of the image a certain meaning. And this is really cool to see. And they are doing this here with these cameras. You get then basically these three-dimensional point clouds where you have distance profiles or depth profiles, and then with this
image information at the same time.
You can then create segmentation of the objects which you are looking at. So we are going back to Automatica. Everything around machine vision and sensor technology will be visible in the Hall 5. I presented you 2 companies, but there are way more companies to look at, and I will probably mainly be in this region due to the limited time of one day. And there's also this machine vision pavilion which I want to look at. And yeah, let me know in the comments if you are interested in one of these companies listed here, and then I might find time to also take a look at them.